So dear student, this experiment to measure the coefficient of linear expansion for solids, okay? So this is the lecture notes, and if you look at lecture notes, we have this diagram for our device. So this box is for this diagram, okay? Let's put my camera here and show what's inside. So in this cylinder, we have a metal installed, and we can heat with the device here and measure with the same device. So you can see some cables. They can bring some electricity to heat the device up. So the metal cylinder is installed inside of this cylinder is invisible. Okay, now we close the lid. Let's show you the device with some details. Okay, so you can see here we have a small scale to measure the change of distance, and you can see. Let's try to make things even closer. That one step is 0.001 millimeter. It's very small scale. Okay. So we need to make sure this end is contact this cylinder. They contact very closely, very firmly. So we can press here. And we need to make sure that this number is in the first half, okay? It's in the middle or in the first half. Because this needle can turn around and this one will go step. If we go out of range, your measurement will become unstable, okay? You're gonna get wrong result. And this device, we can measure the temperature, and we can also heat with the same device, okay? It's a device for measure linear expansion coefficient. There's a Chinese or Chinese English. So the actual temperature here, we can record now, is 25.3 Celsius degree, okay? Now I will show you how to measure the device. Okay. So first thing, I like to make the needle point to 0. Then we can start to, so now it's 0. I will try to set up the temperature here. So let's try to increase the temperature to, for example, say 30 degrees. Then I make sure this is the enter. Then this red light is blinking, means this one is functional. And this screen will show you the actual temperature. So this experiment will take a lot of time. According to the notes, we need to make this number stable. The fluctuating should be less than 0.1 degree. Then we can record, okay? And we set to 30 degrees. This one may end to 31 or even 32 degrees. And you may see this one this needle will start to move a little bit. It will take a few minutes to get stable. So this is how we actually can measure things, okay? I can only show maybe the first step, and for the rest, it will take 20 minutes to get equilibrium. So I will stop recording and only record the data and give you the data, okay? Then you can proceed to the data and write down the report. There's one thing I need to remind you is here. So the equation is the change of the length is proportional to the length itself and times the change of delta t. So you need to know the initial length of this rod. This will be given later, okay? I think in the lecture notes it's written or not, I need to show, yes. So if you look at our lecture notes, it's written here. The metal rod has diameter 8 and length is 400 millimeter, okay? So this length is 400 millimeter. Don't forget that one, otherwise you get wrong result, okay? So this equation, we measured several delta T. So we increase temperature, we measure delta L from here. But afterwards, we can make a plot to measure slope, then you know this alpha. You can see this from the textbook in the chapter of 21 or 20, where we introduce this concept. And there's also a table, you can compare which metal it is. So you can see this needle is moving very slowly, but it's actually moving. So our temperature now is 28.8. The first temperature is 25.3. Now this needle starts to move a little bit. And we have to wait and wait for hours to get things stable. So this all I can tell you, and later I will collect and bring back with you. So I will stop the recording, and I will stop to record this video, but I will start to record the data, and that's all I can tell you for this experiment. Okay. So I will stop here.